In this video, I'll show you how to simplify radicals. Make a mental note that this video is here, so that down the road, if you forget or need more practice on how to simplify radicals, you can just come back and review this video. So, the first thing you need to know in order to simplify radicals are the perfect squares. I suggest and I tell my students is, on any test that involves radicals, to write the numbers 1 through 10 on the top of their page, and then square each number, so that all the perfect squares are handy to them, so when they need to factor them out of something they're taking the square root of, it's right there for them. So, what you would do is just like this, write 1 through 10 on the top of your page, and then go 1 squared equals 1, 2 squared equals 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100. It's also worth knowing that 11 squared is 121, and 12 squared is 144. Just having these at your disposal when you're simplifying radicals is just, when you're simplifying a radical, just going to make your life a whole lot easier. So, let's go and simplify one. So up top, where it says the square root of xy equals the square root of x times the square root of y is the rule that we're going to use to help us simplify radicals. Now I know there's many different ways to simplify radicals, and if you already know a way how to simplify them and you're good at that, then go for it. But I like this method because it really helps you understand why you're able to simplify radicals and understand how to work with radicals. So, let's say I have the square root of 72. The first thing I'm going to do is factor 72. And you could factor any number. So, the key to factoring when you're simplifying radicals is to try to make one of your factors a perfect square. So remember all of those perfect squares we wrote on the previous slide. To yourself, you're now thinking, what is the biggest perfect square that goes into 72? So you might think 9. 9 is a perfect square, and it goes into 72. So we could break up the square root of 72 like this, as 9 times 8. But if we do that, then it's going to take more steps than we need to. So, if we look for the biggest perfect square, then we can simplify this radical in fewer steps. So if you remember that 36 is a perfect square, it also goes into 72. So we're going to rewrite 72, or the square root of 72, as the square root of 36 times 2. You could factor any number. So now, it's like this right here, the square root of two numbers being multiplied. Since it doesn't matter the order in which you either take the square root or multiply two numbers together, we can break that up. We can rewrite that as the square root of 36 as the square root of 2. So again, if you're taking the square root of any two numbers being multiplied, you could take the square root of each of those numbers first and then multiply them together. So now that we rewrote the square root of 72 as the square root of 36 times the square root of 2, we can now simplify that. Since the square root of 36 is a perfect square, we can write that as 6, and then root 2 just stays root 2. So, the square root of 72 is equal to 6 root 2. Alright, let's do another example right here. 2 times the square root of 24. It works exactly the same way, but you just want to keep the 2 out in front, and then remember to multiply it by whatever new number comes out in front of the radical, outside of the radical. So I'm just going to leave the 2 right there. And then I'm going to break up the square root of 24 as the square root of 4 times 6, because 4 is the biggest perfect square that goes into 24. And if you accidentally don't pick the biggest perfect square that goes into a number, it's okay. You'll just have to do another step in order to simplify the radical completely. So now I'm going to rewrite the square root of 4 times 6 as the square root of 4 times the square root of 6. So now I have 2 times the square root of 4 times the square root of 6. 3 separate quantities being multiplied together. Well, the square root of 4 can be simplified because it's a perfect square. So now I'm going to rewrite it as 2 times 2 times the square root of 6. Well, 2 times 2, that would be unsimplified if we left it like that. We know that that equals 4, so we can rewrite that as 4, and then the square root of 6 just stays the square root of 6. So the square root of the square root of 2 root 24 becomes 4 root 6. Alright, let's look at more of these examples with the numbers in front of the radicals. So when you multiply two radicals together, the numbers outside the radicals, they multiply together and stay outside the radicals, and the numbers inside the radicals multiply together and stay inside the radicals. So this first example right here, 2 root 2 times 3 root 7, we're first just going to rearrange it so it looks like this. 2 times 3 times the square root of 2 times the square root of 7. Well, 2 times 3 is 6, so that stays outside the radical. And root 2 times root 7 can be written as the square root of 2 times 7. We know that the square root of 2 times 7 is 14, so our final answer is just going to be 6 root 14. So all of these middle steps right here, after a while, you might not have to do them. You might be able to kind of do them in your head. But when you first start doing radicals, it's really important to write out each step. So another important thing to know is that always check this number inside the radical and make sure it can't be simplified anymore. And the way you do that is to make sure no perfect squares go into it. So 1 doesn't count, 4 doesn't go into it, and 9 doesn't go into it. So the next perfect square is 16, which is bigger than 14. So obviously no perfect squares are going to 14. So this is our final answer, 6 root 14. Alright, if we look at this example, same idea. We're going to take the 3 and the 2, multiply them together outside the radical, and then take root 6 and root 10 and multiply them together inside the radical. So we get 6 root 60. Alright, pretty much done, but now we want to make sure that no perfect squares go into 60. So the only perfect square that goes into 60 is 4. So I'm going to rewrite 60 as, and make sure you leave the 6 out in front. The biggest mistake I see is that students forget about that 6 and then their answer is off by a factor of 6. So don't forget to multiply that in at the end. So it's 6, and then I'm going to rewrite 60 as 4 times 15. So it becomes 6 times root 4 times root 15. Now we have 3 numbers being multiplied together. So now you could take root 4 and rewrite it as just 2. And 15, since it's unsimplified, it's not a perfect square, that's going to stay at, well, it is simplified, it's just not a perfect square. It's going to stay under the radical. So 2 times 6 is 12, and our answer is going to be 12 root 15. Alright, now let's look at radicals and division. So just like you can take the square root of 2 numbers being multiplied together, or write it as the square root of each number being multiplied together, and then, take the square root of each number and then multiply them together, like in the previous example. Similar thing works with division. So if you have a fraction where the numerator and the denominator are both being square rooted, like right here and here, you can rewrite that as dividing the numerator and denominator and then taking the square root of that quotient. So right here, the square root of 15 over the square root of 5, the order of the division or the square rooting doesn't matter. So we can rewrite this as the square root as 15 over 5. So in the first case, in the original problem, we were taking the square root of the numerator and denominator before we were dividing. Now we're going to divide before we take the square root, which makes life a whole lot easier because 5 goes into 15. So the square root of 15 over the square root of 5 just becomes the square root of 3. Alright, the opposite also works. If we have the square root of an entire fraction, and that fraction can't really be simplified because no perfect squares go into it, we can rewrite that fraction as the square root of the numerator divided by the square root of the denominator. And then, since we'll learn in the next slide that you can't take the square root of a denominator, that we can just rewrite the square root of 4 as 2. So our final answer would be root 3 over 2. So the order of taking the square root and division doesn't matter, and the order of taking the square root and multiplication also doesn't matter. Adding radicals. It's actually pretty easy. It's just like adding variables. You can only add like radicals. So in this first example, we have 2 root 5 plus root 5. So those are like radicals because the number under the radicals are identical. So we can add them just like we would add 2x plus x. 2x plus x would be 3x, so 2 root 5 plus root 5 would just be 3 root 5. So you add them just like variables. They have to be like variables, and then once they are, you add the coefficients. So here, we have 3 root 3 plus 5 root 5 plus 2 root 3. So notice that 3 root 3 and 2 root 3 are both like radicals, and 5 root 5 is different. So we can add the 3 root 3 and the 2 root 3, but not the 5 root 5, because again, those are unlike radicals. So I'm going to take 3 root 3 plus 2 root 3 and add those together. So 3 root 3 plus 2 root 3 becomes 5 root 3. And then 5 root 5 just stays as 5 root 5. And that's our final answer. So again, you can only add like radicals. Alright, and last thing that I mentioned earlier that I want to review is, there's two things, sorry. Squaring a radical. Now, squaring and taking the square root of something are inverses. So in other words, they cancel each other out. So in the first example, the square root of 9 squared is just 9, because the square root of 9 is 3, and then if I square it, that's also just going to become 9 again. Same thing with the square root of 7 squared. That's just going to be 7. When I have the square root, 2 root 5 squared, so a number times a radical being squared, we square both of those. So, because 2 root 5 squared is really 2 root 5 times 2 root 5. So 2 times 2 is 4. Root 5 times root 5 is 25. So then this becomes 4 times 5, which is 20. So pretty much you square both of those things. And multiply them together. Sorry, I don't know why that thing disappeared. But the answer should be 20. And the last thing that we'll do is simplifying a fraction with a radical in the denominator. Alright, a fraction is considered not simplified if there is a radical in the denominator. So to get rid of it, you multiply the numerator and the denominator by the radical in the denominator. So in this case, 3 root 2, we're going to multiply the top and the bottom by root 2, because root 2 is the radical in the denominator. So I'm going to multiply the top and the bottom by root 2, which I could do because root 2 over root 2 is equal to 1. Whenever you have a fraction where the numerator and denominator are the same, that's equal to 1. Multiplying anything by 1 doesn't change the value of it, so we're not doing anything wrong here. So when you multiply across, 3 times root 2 is 3 root 2, and root 2 times root 2 is 2. 3 over 2 can't be simplified, so that's our final answer. I think that's all. Don't remember what's on the next slide. Yep, that's it. Alright, so remember to come back and watch certain parts of this video if you're struggling with radicals down the road, and have a good one.